So, here we are again, Malban here. And this is my Vectrex and my computer. And it's going to be about PiTrex again. Something I did the last couple of days, or nearly 2 weeks, I think. Something that I thought could be done in a few hours, which took a couple of weeks, is the connection between the PiTrex and an emulator running on the PC, MAME in this particular case. So I'm going to switch on my PiTrex and I'm showing you a version that more or less works. More on that later. Okay, this is my PiTrex as you can see, and my Vectrex. And you can navigate, well, you can't because you don't have it, but I can, and there's a new program over here, vTerm. Perhaps it's going to be PyTerm, or I don't know. This is a terminal program that connects the PiTrex to the PC via a serial cable, and it's using 900,000 baud to communicate. It's doing that over the mini UART that's on the Pi Zero, and that connection is not entirely reliable. This is what caused me some trouble, and some other things which I might mention later or not, because they were really frustrating. But anyway, I'm going to show you something that works, that is nicer than just talking about it. So if you press the button, then the program starts and it's awaiting MAME. On the computer side, I've got here my command line interface, and I'm going to start MAME with Lunar Lander at first. So this is, I'm positioning the screen of MAME so that you can watch it in parallel. This is about it, and this is a start screen of any emulation, and you can see the Vectrex PiTrex has already communicated with MAME, and it's displaying that it will play Lunar Lander, and Lunar Lander has a frequency, natural frequency of 41 Hertz. The Vectrex will still display in 50 Hertz, but the connection and the frames will be updated with 41 Hertz. This is what they just well, communicated about. And if I press return and the game start, then you should see it on the PiTrex. So you can see those both in parallel. Yeah, well, actually Lunar Lander with my last doings on the computer, on the PiTrex, is actually better in the, so to say, native PiTrex mode. It certainly works here. You can insert coins somewhere and play it, and I can play it using the keyboard, and you can hear the sounds of MAME. You can see that it works, but actually the connection, the speed is about 77%. It's not 100%. If you play it on the PiTrex in the native mode, which I implemented the last 2 weeks, it's playing in 100%. So this is a little bit faster. This has actually to do with, well, the speed of everything. What you see here, I don't know, are about 500, 600 vectors which are communicated between the two. And this is about 1500 to 1700 bytes per frame. And you can do some calculations with 900,000 baud. It's about 20 milliseconds. That's the communication between the two takes. And 20 milliseconds, that is 150 seconds, which is already the complete time it takes to transfer the data between MAME and the PiTrex in one PiTrex frame, because it runs in 50 Hertz. So, well, there's not much time left if you have to communicate for 20 milliseconds, and then you also have to display the thing. So it's natural that this is a little bit slower. There might be some tricks which I might implement further down the road to speed up the communication or to shrink the data that is transferred, but I already did a little bit, but it's not perfect. But you can see, I just stopped MAME on the computer. The PiTrex is jumping back into the waiting mode for MAME, and then it expects the next display. Very vector intense emulations certainly do not run well. It's just too many vectors. As you can see, Lunar Lander is already on the brink. What you can play, but which you can also play much better on the actual Vectrex by now, is, for example, where have I got it? I'm scrolling here through the things I called before. This is Asteroids, but it's spelled Asteroid, not Asteroids. 61 Hertz, and there you can see, if you press F11 on MAME, it runs in, no, you can't see it. Oh, I'm going back again, it started again, and I position the screen correctly so you can watch it. The thing is, the communication between PiTrex and MAME during the game must not be disturbed. This is due to the mini UART. And if I position the window while in the game, the MAME actually halts and also halts the communication to the PiTrex, and then it jumps back to the communication screen. So if you want to position the window, do it at the start of the game. So anyway, as you can see now, this Asteroids runs in 100% speed, which is only logical because there are not so many vectors on the screen, and you can actually play it. You can, oops. Okay, you can play it on the. Actually, you can't play it on the computer because I configured the Vectrex joystick. You can also configure the Vectrex joystick. As you can see here, I am playing with my Vectrex. You can do that in MAME. If you go to the input settings, input devices, here you can see I added an input device to MAME. It's PiTrex input. And here you can see if you have the controller, if you press button 1 is recognized, 2, 3, 4, up, down, left, right. You can toggle if you want to use analog mode. Analog mode enabled, it's at the moment disabled, it shows a 0. But if you press button 1, 2, 3 and 4 together, 1, 2, 3 together, then you enable or disable it. So now it's in analog mode, the joystick, and here you can see the analog is also transferred. So you can actually use in PiTrex your Vectrex controller if you configure the MAME games. Okay, let's go out of here again. This was you can actually really play some games that you can as yet not play very well on the PiTrex. Tempest looks pretty good, but Tempest will probably be the next game that I try to implement better on the PiTrex. This is because I still have my controller which I got especially more or less for Tempest, and I've never really done anything with it, and I'm just owe it to a friend that finally I do something worthwhile with it. So probably Tempest will be the next thing I do. So okay, as you can see here, it's displaying it's not, the speed is not 100%. You can't see the speed. I do it very fast, so it's about 80% the speed. In-game it's a little bit faster. The thing is, there are also very many vectors displayed. You cannot see it, but the shots you do are actually dots, and I don't know how many dozens of dots your own shots are. So this is well, actually time consuming. But if you play a game, usually during the game the frame rate is pretty well. 10 coins, start a game. I don't know, have I configured the joy? I think I not 100. I configured it a little bit. Yeah. I still you can see it. I tried optimizing the driver a little bit, and I'm at the moment I have a version compiled that does not transfer dots, or it only transfers 10 dots at the moment. For some games this is good. If you play Star Wars, for example, the dots, the stars are not that important and you can get a better frame rate. But for Tempest, as you can see, the shots consist 100% of dots. You cannot see your shots anymore. So this was one optimization I tried, but which well, was not, in the case of Tempest, not so successful. Yeah, most of the time this is actually working pretty well. Let's see, what else have you got here? Star Wars. You will see Star Wars is still too slow because there are so many vectors. It's in native mode with the static binary compile. It's probably better, but if you want to have the correct sound, it's probably better on in this mode. It's a little bit scratchy, 50%. It's not too bad and not too good. Yeah, I've configured the joystick. Also, it's a little bit touchy. I think I've got middle now. Anyway, this is now MAME playing with a. I'm so used to the PiTrex. The joystick behaves differently than on the native PiTrex, and I'm totally confused playing it. So this will not be very well what I'm doing here. I think I should inverse the controller direction. This is what's confusing to me at the moment. Yeah, this is. You can see the dots that are missing, or you can't see the dots. Anyway, another arcade emulation. So what you can see here is actually a Pi02 running, and the serial communication is running in one core, and the display output is running in the second core. So this terminal mode actually makes very good use of the PiTrex, of the Pi02. And it's a sad thing to say, but it does not work well on the Raspberry 01. I'm going to switch to the 01, and then you can see what I mean. The thing is, well, the speed. You only have so much time to do things. As I said before, running in 50 Hertz, you have 20 milliseconds to do everything, and the baud rate of even 900,000 is, well, pretty slow, as I mentioned before. I'm not sure how I configured my Pi0 right now. I just started up 01. I have to put in the SD card, otherwise nothing will happen. Oh, this is the same SD card that I used in the Pi02 just now. PiTrex, yes. This looks exactly the same, but you will see it still looks the same. Let's start Asteroids. Looks bad enough, I think. What's one moment? Error opening serial port 5. It doesn't get the COM port. This is because this is another serial device, and per default my virtual machine grabs the USB device, and here you see it, the UART is grabbed, and so the serial connection was already taken, and MAME could not take over. So I'm starting now. Okay. This looks not too bad, actually. I think this is a non-interrupt mode. In non-interrupt mode, the display is not garbled. but it is very slow. As you can, I don't know if you can see it in the video, but it's flickering now. That it did not flicker before. If you look at the speed, it's not 100% anymore. Even with those few vectors displayed, it's at 77%. This is just yeah, well, it's doing all timing critical things in one core now. Well, because the Pi 01 only has one core, and at least half the time it does a communication with the computer over serial interface, and the other time it has to display the things. It looks clean, but it's slow. And if when even Asteroids is so slow, well, you can imagine that most other things are also too slow. I'm going to compile another version because it's not on the SD card right now, and I'm going to do that live. This is my Ubuntu virtual machine. I'm getting the SD card, putting it into my computer, and this is actually the source code, and I'm enabling interrupts. Save it and compile it and switch the SD card, and then you can try the other version. It's totally complicated, and I've heard rumors how complicated it is to get one program from the computer to the PiTrex. It's just simply swapping the SD cards. It's a matter of 5 seconds. I don't know why that is so difficult. Actually, I have implemented a program with which I can pass the image file from the computer to the PiTrex without swapping the SD cards using the serial interface. But you know what? I'm still swapping the SD cards. It's somehow less hassle for me. I don't know. It's not such a very terrible bad thing that you can't develop for the PiTrex if you have to switch these things in 2 seconds. But anyway, I digress. This is now the same program, but this time interrupts are enabled, and it is faster, so the speed will be better. But you can see another thing. This is, yeah, okay. The speed is now 100% again, but as you can see, the screen is garbled. There are always disturbances which look pretty ugly, and I have not been able to circumvent these. The thing is, you have to die one death. You can either not communicate all vectors via the serial interface, or you cannot display. The thing is, in the interrupt mode, well, as the name says, all communication with the actual Vectrex, with the wire, which must not be interrupted, occurs in the interrupt, and as such it cannot be interrupted. Because it is absolute timing critical to get the vectors right. Now, what you might think, it looks pretty interrupted now, so the timing is not correct. No, that is not the case. The case is the vectors are drawn exactly as they are gotten from MAME, but the communication through the serial interface is interrupted. So there are several bytes missing in each frame, and the missing bytes are what causing these strange vectors, because the end coordinates or the start coordinates or sub-coordinates of lines are not gotten correctly. And this looks nearly exactly the same as if the wire was not correctly addressed. I tried many things to forbid interrupts in the time, to have critical zones, to get better timing, but the crux is I was not successful. One thing or the other was always crooked. Either the serial communication or the display within the interrupt. And actually I gave up. For now, the vTerm or PiTerm program for me only makes sense with the Pi02. There I can use the SMP, the multiple cores, and as you have seen before, the communication works good. Well, in principle, that was all I wanted to show you. There is now a vTerm. You can communicate with MAME. You can use the actual Vectrex controller. That is working fine as long as you have got a Pi02. There are still some optimizations pending, which I will probably introduce. What took me so long? Well, first to figure out that I should use a Pi2. That took me a week because, well, I tried. I tried long and hard and it did not work well enough. The other thing, MAME, the source code. I know now more about MAME than I ever wanted to know. How you do things, how you insert joysticks, new controllers, how you enter dip switch menus, how you insert device drivers and so on. And what I wanted to do was to keep it all in one place. I did not want a new complete MAME distribution. I wanted to keep it in one place. So everything I did with MAME that you could see, the input devices, the controller, you can fetch data from the vector.ini. There you can configure which COM port to use and so on. Everything I did from the one file vector.cpp, the one class file of the vector display. From there I configured the complete MAME with joystick input, with input settings, with a menu, with a serial communication. There's a switch or defines whether it runs in Unix or under Windows, although I have not compiled it under Unix because I only have Ubuntu 16, and for some reason or another the newest MAME version does not compile under, at least not the package you get from GitHub directly with my configuration. Funnily enough, it compiles out of the box under Windows. That was very unexpected. Yeah, so this is the complete MAME version 277 with only one file changed, namely the vector.cpp. Everything else is completely the current MAME distribution. To enable your MAME to do what you just saw, well, you only have to exchange one file and compile it yourself. That goal, at least, I reached. So, this is it for now. I'm going to write a little bit on my pages, but essentially, since I'm going on a vacation for a week, or at least I'm not at home for a week and have not access to Vectrexes, this will be it for now, and perhaps I'll pick it up in 1 week, or perhaps not, or do something else, but it was a very PiTrex-y time the last couple of days, and I will probably follow up with more PiTrex. As I said before, I will probably look at Tempest next, or perhaps do some more optimizations with vector count, or finally do the drawing routines or something else I can think of. Anyway, bye for now. Ciao.